let us continue to solve those some problems. In the first unit itself, we are left out with many different kinds of topics. So we'll continue with the problem solving, and then tomorrow maybe hopefully I think I have completed all the different kinds of problems which comes under first unit. Now I'll go for the second unit later. Okay, as the chapters comes in the textbook, I'm giving the problems. Anyway, let us solve some problems here. So this is like recursive functions. What we are going to do today. Yesterday we on functions we have solved some problems. One-to-one function, on-to function, this kind of things. I'm trying to make at least minimum one problem from different kinds of way we ask the questions actually, and each topic. So for each topic, minimum one topic I'm trying to make it, right? So let us solve some problems today. Suppose that a person deposits $10,000 in a savings bank account at a bank yielding 11% per year with interest compounded annually. How much will be in the account after 30 years? No, you all know simple interest formula and compound interest formula basically. So what will be happening after 30 years? You can use compound interest formula and make it, but here we want to ask to solve it in the form of recurrence relations, or let me say like recurrence functions. Okay, so how will you express this particular question in the form of a recursive function? First point in solving this question is, how do you express the recursive function for the given problem? Okay, so if you say P naught is the principal interest or present amount, that is $10,000. So after 1 year, how much the amount will be? So P1 means after completing first year. So how much we will be having? That is nothing but P naught plus 11%. 11% means 0.11. 0.11 into P naught, isn't it? So P1 equal to P naught plus 0.11 into P naught. So this continues every year. So we are going to write a general formula in that. That is Pn equal to Pn minus 1 plus 0.11 Pn minus 1, like that. So n we are going to substitute 30 to find out the value. So like this we are going to have. So as I told you, how you are going to get this formula, it is indicated. So Pn is Pn minus 1 plus 0.11 Pn minus 1. So that is nothing but 1.11 into Pn minus 1. So the initial condition is P naught equal to 10,000. So how you calculate that one? So here P1 equal to 1.11 into P naught. So we'll have substitute 10,000 in place of P naught and calculate P1. Similarly go for P2, P3, so on to Pn actually. So this is the recursive function how we are defining. If you keep on doing that, now I am asking for 30 years. We cannot calculate 30 times, or let me say like after 70 years how much it will be. It will be very tedious to go 70 steps and calculate it. So what we will do is we are going to find the solution for this. Finding the solution in the sense, in this fashion we are going to make P2 equal to 1.11 whole square P naught. So that is Pn in terms of P naught. If we are able to find, that is nothing but the solution of your recursive function. So when you are able to make Pn in terms of initial value P naught, then it will be easy for us to calculate the result. Now in this particular case, you can substitute 30 in place of n and calculate P30. So P30 is equal to 1.11 whole power 30 into 10,000, which is nothing but this much dollars. Okay, is this clear, all of you? Any doubts in this?
No, ma'am. No, ma'am.
Okay. Next, try to solve this one. Show that the sequence an is a solution of the recurrence relation an equal to an minus 1 plus 2 into an minus 2 plus 2n minus 9 if an equal to minus n plus 2. So what we will do is, in place of in this particular equation, we are going to use this formula and prove that one. This is the solution actually. So, okay. So try to solve this question. I'll give the solution. Try to solve it. Yeah, did you complete? So here goes the solution like this. First find out an minus 1, then you find out an minus 2 and substitute these values in your given expression, that is an minus 1 plus 2 an minus 2 plus 2n minus 9. Substitute these two, that is an minus 1 as minus n plus 3 and an minus 2 as minus n plus 4. Substitute these values. So you'll have in this fashion. Solve the obtained expression here. We are getting it as minus n plus 3 plus 2 into minus n plus 4 plus 2n minus 9. So just removing the parenthesis and solving it. Now you can see that minus 2n plus 2n cancels and 3 plus 8 minus 9 gives you 2, that is plus 2, and minus n will be left out. So minus n plus 2 will be the answer, and you can observe that minus n plus 2 is your an actually. So I am writing it as an. So we have considered the RHS and we have showed that it is equal to the LHS actually. So because we were able to prove that LHS is equal to RHS, so obviously an equal to minus n plus 2 will become the solution of this recurrence function or recurrence relation. Okay, now try to solve this one. Fine. Now previously in this question we have given the solution to you, and just we are asking you to show that this is a solution, and in this particular question we are asking you to find the solution for the recursive function, I mean recurrence relation. So find the solution to each of these recurrence relations with the initial conditions given. Use iterative approach. Okay, so an equal to an minus 1 plus 3. So already I have told you how to find the solution in the first problem itself. So how do you go with, no, like an minus 1 equal to an equal to an minus 1 plus 3. Now in place of an minus 1, we will get an minus 2 plus 3. Already 3 is there, so plus 3. So what will happen? It is becoming as an minus 2 plus 3 into 2. Don't make it 6. Write it as 3 into 2. Okay. So now an minus 2 will become as an minus 3 plus 3 plus 3 into 2. So what will happen? An minus 3 plus 3 into 3. Like this we are getting. So can you generalize this one? Can you generalize this one? So when you will get a naught n minus n. So when here you see that n minus 1, 3 into 1. When you are having a n minus 2, it will be 3 into 2. So when you say like a n equal to a naught, when you will get a naught, n minus n it will become. So 3 into n. So a n is nothing but a naught plus 3n. Okay. So what is a naught? 1. So what will become a n? 1 plus 3n. Okay. Are you listening?
Yes, ma'am.
So that is how your solution goes, and that is nothing but an is equal to 3n plus 1. You can just go through once again. I have just orally told you, and you can go through once again. What is that? Which class is going on beside? Is this clear, all of you? Problem 3?
Yes, ma'am.
Yes, ma'am.
Let's go for the next one. Suppose that the number of bacteria in a colony triples every hour. No, like let me say number of bacteria is 10 at this particular moment. Now let us say that it is 11:30. So if the bacteria triples by 12:30. Now if I say 10, 3 into 10, right? 30 it will become. So by 1:30 again 3 into 30, that is 90 it will become, right? Like that. Now set up a recurrence relation for the number of bacteria after n hours have elapsed. So obviously, you know, like if I say present in moment as a naught, we are supposed to find an, right? So what will happen? A1 is 3 into a1. A1 equal to 3 into A2, like this. So what will happen to AN?
3
AN
into n minus
3 into
n minus
1.
1.
Recurrence relation, right? So your solution will become as AN equal to 3 into AN minus 1. Okay. Suppose, yeah, okay, fine, then I'll not confuse you. If 100 bacteria are used to begin a new colony, what is this condition actually? If 100 bacteria are used to begin a new colony, in the sense, initial value is 100. Okay, that is, let us say A naught is 100. How many bacteria will be in the colony in 10 hours? So n is going to be 10. N is equal to 10 and A naught is 100. So how will you get the answer for the B part? You have to solve the first part. That is an equal to 3 into an minus 1 we have given. We have to get the expression such that an in terms of A naught actually. So what will happen in such a case? An, how will you express in terms of A naught? What will be the expression? Let me know. Replace an minus 1 with 3an minus 2, right? So what will happen? 3 square. So an equal to 3 power
n into a naught.
an equal to
3 power n into a naught.
yes, an equal to 3 power n into a naught. So now you have the formula an in terms of a naught, and a naught is given as 100 and n is 10. That is a10 you are supposed to find. So what is the answer? What is the answer for the B part?
3 power 10 into 100.
3 power 10 into 100. Yes, a10 equal to 3 power 10 into 100. So your answer goes like this. Okay. You can go through if you have any doubt. Clear all of you? Any doubt in the problem 4?
No, ma'am.
Okay, let us go with the problem 5 then. So determine whether the set of integers not divisible by 3 is countable or uncountable. So first thing is we are supposed to determine whether the set of integers, means like first you have to determine the set, and then you have to find whether that set is countable or uncountable actually. So what is the set you are supposed to determine? The set will be having an elements in such a way that they are not divisible by 3. So whether it is a countable or not, yes or no, the question. So let me say like 1, 2, 4, 5, right? These are not divisible by 3, isn't it? 5, then 7, 8. No, besides the multiples of 3, I can consider the rest of the values basically, right? Yes or no? And because we are telling it as an integers, it could be a positive integer or a negative integer. So both the things will be included. So positive values and negative values. So I can say it as a -1, -2, -4, -5, like this. All kinds of things we can consider actually, right? So obviously because integer itself is a uncountable set, and definitely no, this particular value means like the set of integers not divisible by 3 also is uncountable, isn't it? Yes or no?
Yes.
So the answer for the first question is uncountable. So for those that are countably infinite or uncountable, both are same. Countably infinite exhibit a one-to-one correspondence between the set of positive integers and that set. Now, so what we want to go with the second question is we have to define a particular function such that one element you have to take from the set. That is one element which you are going to consider in the set which is not, I mean, in a set of integers that is not divisible by 3, and the other one is set of positive integers. So you are supposed to have a match actually, one-to-one correspondence you have to make actually. So how we are going to do that? So the first one is that A of all integers not divisible by 3 is countably infinite, as we all know, because the set A contains an unlimited number of elements, and the following definition of F is a one-to-one correspondence. So this is the reason for the first question, or let me say like A part, and the second part answer is this one. So here we are taking it as Z plus is a set of positive integers and A is set of integers that are not divisible by 3. So we are making a one-to-one correspondence. How we are going to make? So f of n is defined in such a fashion like 3 into n by 4 minus 1 plus 1. So here, if n is divisible by 4, then we are going to map such a fashion actually. Now that positive integer is going to be mapped to this. So I'll let you know, like let me say like positive integers means it will be starting with no like 0, 1, 2, 3, 4, 5 like this, isn't it? So will we include 0 in the set of positive integers? This is a question to you. Find it out. So here, suppose let me say like 1, 2, 3, 4. 4 is divisible by 4 actually. So in such a case, 4 will be mapped to this one. How it is being mapped? 4 by 4 will become 1. 1 minus 1 will become 0 plus 1. So that will be 4 will be mapped to 1 here. Okay, like this. And then if n minus 1 is divisible by 4 and n greater than or equal to 1. So what will happen here? Suppose if I say like n equal to 2. Okay. So if n, if n equal to 5. What will happen if n equal to 5? N minus 1 is divisible by 4 because n equal to 5, n minus 1 is 4, 4 will be divisible by 4 like that. Or you can take 9 also. Suppose if you take n as 9, so what is happening? 9 minus 1, that is 8 is divisible by 4, right? So what is n here? N is 9, 9 minus 1 is 8 divided by 4 is 2. 2 into 3 is 6 plus 2. It will be mapped to 8 like that. 8 is mapped to 8. Like this, we are defining different kinds of functions actually. So here 3 into n minus n by 4 minus 1 plus 1 if n is divisible by 4. In the next part, n minus 1 is divisible by 4, and the next part, n minus 2 is divisible by 4, and minus 3 is divisible by 4. So here if you see, a will be having both positive and negative integers, but here you will be having, and z plus will be having only positive integers. So what happens here is, the first two lines give all positive integers not divisible by 3. These two. All positive integers no like not divisible by 3. And the next two will be giving you the all negative integers that are not divisible by 3. So what is happening when we are making in such a fashion, like different cases which are not being divisible by 3, then here each and everything is going to be mapping to each and other value. So we say that this is one-to-one correspondence actually. So this is a bit research kind of question, because in order to get these questions, you should be very careful. I'll let you know like a simple logic here, how you are going to get these expressions. Now, here we are talking about the number or let me say like all the integers not divisible by 3. So when you divide any number with the 3, no, like if the remainder is 0, we say that it is divisible, right? So when we say that it is not divisible, when we have what will be the reminders in such a case? No, like if we get reminders, then only we say that it is not divisible. So what will be the reminders? So 1 and 2. So because we are talking about the integers, we will be having both the positive and negative integers. So the reminders could be -2, -1, 1, 2, right? -2, -1, 1, 2. The 4 reminders is possible in this particular case. So that is the reason why we are having 4 different cases. Okay. And if you observe, here it is like the same thing, n minus 1 by 4 by plus 2. And this one, you can consider it as n plus 1, or the value what is given here 3 plus 1. That you can consider. Suppose if I give a question, let me change the question, that a set A of all integers not divisible by 5. Okay, so what will happen? How many values will be here? So when you divide a number with 5, how many reminders will be there?
1, 2, 3, 4, ma'am.
1, 2, 3, 4. So positive 1, 2, 3, 4 and negative 1, 2, 3, 4. Totally 8 combinations. That means like 8 different expressions you are supposed to give actually. Okay. So as that, like when n is divisible by 6, let us say. Because 5 plus 1 we are going to say. If n minus 1 is divisible by 6, n minus 2 is divisible by 6, n minus 3 is divisible by 6, n minus 4 is divisible by 6, n minus 5 is divisible by 6. That's all. You stop there. Like this we are going to write actually. Okay. Yeah. Now, yeah, here we are taking like divisible by 4, right? So how many combinations you are going to get, that value you take. Why we are telling if n is divisible by 4, it is not like 3 plus 1 actually, because we are having 4 reminders, we are taking 4 here. When we are taking 8 reminders, we are supposed to say if n is divisible by 8, like that. Okay. Then is this question clear? Problem 5.
Yes, ma'am.
Then problem 6, next question. What are the greatest common divisors of these pair of integers? Let me say change it. What is the GCD of this pair? This is one value, 3 power 7, 5 power 3, 7 power 3 is one value. 2 power 11, 3 power 5, 5 power 9 is another value. What is GCD? Let me know.
Three power five into 5.
3 power? 3 power
5
5
into
into
5.
5 power?
5 cube.
5 power 3.
5 power 3. Yes. So how you will be calculating the GCD if you are giving the question like this? It is a very big, like numbers, right? So how will you calculate the GCD if the numbers are given like this? Now we have to take the base, that is 2 we are having for the second number. We don't have like for the first number, whatever it is. So we are going to take 2 power minimum of 0, because in the first number it is not there. 0 comma 11 into 3 power minimum of 7 comma 5, 5 power minimum of 3 comma 9, 7 power 3 comma 0. I mean minimum of 3 comma 0. Like that we are supposed to take. But here we are doing directly, because we are anyway minimum of 0 comma something, no, like if it is not there, what will happen? 2 power 0, right? So it is becoming 1. So I am taking only the values which are in common for both the pairs actually. I mean both the numbers. So 3 power minimum of 5 comma 7, 5 power minimum 3 comma 9. So it is 3 power 5 into 5 power 3. This is how we find the GCD. Yeah. The next question. Find, okay, in this particular case, can you find what is the LCM? What will be the LCM here?
2 power 11 into 3 power 7 into 5 power 9 into 7 power.
Yes. Instead of taking minimum, you are supposed to go with a maximum actually. So what will happen? 2 power 11 into 3 power 7 into 5 power 9 into 7 power 3. Okay, that will be your LCM in this particular case. Fine. Find the prime factorization of each of these integers. So when you are going to find, I have not given the solution for this question actually. Please try to make it. Find the prime factorization of each of these integers. So 88. So what we do is we'll start dividing from 2, obviously. So what will happen? So first one. So let us say 88 divided by 2 is equal to 44. I'll just continue like this until we'll get that one. So we'll take denominators as our prime factors. Okay. Okay. Now, what will be the prime factors for this?
2 into 2 into 2 into 11, ma'am.
Yes. So this is how your prime factorization will be, right? Prime factorization of 88 is 2 cube into 11, right? You can write like this. Yeah, we cannot make it as a 8. Remember that one again. Okay. So yeah. And what will be for 909090? It is a big number. I'm leaving the like solving this one by you people. Solve it and let me know the answer in the next class. Okay. And then
Ma'am, 2 into 5 into 3 square into 10101, ma'am.
okay.
10101.
So let me know once again. I'll just write it so that all others will be making a note of it. Of 901090. Yeah, can you tell me?
2 into 3 square into 5 into
Into
3 square into
3 square into
5 into
5
10101, ma'am.
10101.
1. Yes.
Is this not divisible by anything? Is 10101 is a prime factor, prime number?
No, ma'am.
Then
It is divisible by 3, ma'am.
you do it. So if you divide by 3, what will be the answer? So 9. 3. 3.
3367.
3367, right? So I can make this as 3. So 3367 is not divisible by anything, 7 or 9 kind of thing.
7. It is divisible by 7, ma'am.
Do it then.
7 into 481.
7 into 481, right? So 481, is it divisible by 3 again?
No, ma'am.
No. It is not 5, 7. Anyway, we have come to 7 actually. So is it 7? No, you need not go back to 3 actually. So by 7, is it possible?
It divisible by 13, ma'am.
13. Okay. So 13 into
37, ma'am.
37. 37 is a prime number, right? So this is the prime factorization of 909090, right? Clear all of you? Yeah. Okay, fine. Then let us go for the next one. So here, this one. Find GCD. I am halfway part in solving this actually. Find GCD of 1625 and LCM 1625 and verify that GCD into LCM is equal to 1000 into 625 actually. So we are supposed to verify this one because the numbers are big in value. So what we want to do is because, and you can easily observe that both can be expressed in some like pi powers or kind of thing. So we are trying to express A as 2 power 3 into 5 power 3. Now if we know, we already know that if we are able to express in powers, then it will be easy to calculate GCD and LCM. So whenever you are asked to solve some problem to find a GCD and LCM, try to express the numbers in powers actually. Okay, so that it will be easy for you. So A equal to 2 power 3 into 5 power 3, B equal to 5 power 4. So here we are having GCD as obviously like 5 power minimum of 3 comma 4 is 5 power 3, that is 125. So what is LCM here? LCM will be 2 cube
into 5 power 4.
5 power 4, right? Because we are considering the maximum value. So LCM will be this one. So what we are asking you to prove it. So let me make it 5 power 3 itself. Okay, GCD value into LCM. LCM is 2 cube into 5 power 4. So here I'll make that one. And then, so what is your A? Now we are supposed to make it that as A into B actually, right? A into B, right? So here you can see that 2 cube are there, and 5 cube, 5 power 5, 5 power 4. Only the order has been changed, that's all, right? So it can be easily observed that one, both are LHS and RHS are same actually, right? So because we have expressed in powers, it is easily observed actually. Suppose if you are finding in numbers itself, mathematically, how you have learned in schooling, then it will be very difficult because GCD you will be finding, LCD, LCM you will be finding, you will multiply those two values. Again, A and B you will multiply, and then again you will verify whether those two are equal or not actually, right? So this much, these many computations will be there. Not like in the previous case, but here using Euclidean algorithms and all like these cases, it will be easy for us to verify the inequality also. Clear? So this is about your GCDs, problems related to the GCD LCM. So we have gone through related to your recursive functions, prime factorization, and countable, uncountable sets, and then also last one, GCD LCM actually, right? So these are all topics we have gone through today, and in the next class we will be going with the rest of the topics actually. Okay, any doubts in the today's class? Yeah,